So hello everyone. My name is Yoav. I'm a mobile developer in the past 1 year and a half in the platform team in Wix. And today I'm going to talk about state management in React, which in my opinion is one of the most important things because as you know, the product manager gives us, he knows to define all the states of the application. He knows to do it in a wireframe, and sometimes we get the design. And our job is, as developers, is to make it work and to make it work right. And apparently it's not such an easy thing to do because you will see a lot of bugs that related to state management, also in Facebook and YouTube, and a lot of applications when sometimes the data is not updated as expected. So I'm going to talk about this today. Just to understand here, who use external library in React? Who use Redux here? Redux, okay, that's good. Mobix, someone? Yes, Mobix, okay. So it's gonna be, eventually I will talk about Redux, but I will start from the basics before I'm talking about even about React. So let's go a little bit to the basics. Okay, 15 billion years ago, the Big Bang. No, I'm kidding. Let's go a little bit forward. Imperative and declarative. Okay, I try to find a good explanation about the difference from imperative and declarative. And I will do it with nice example. While the imperative says, go to the kitchen, in the right corner there is a cup, and in the left corner there is a coffee. Put 2 spoons of coffee and 1 spoon of sugar, hot water, and a milk. The declarative will say, bring me the coffee. And that's basically the difference, and that's what we wanted to achieve as a programmer from the beginning. It's much easier for us to declare things instead of elaborate each command. If you can declare something, and it will be done as expected, so it will be great for us. And if we see here examples for imperative languages, there is, of course, assembly. Oh, I have this, right? It works?
Not quite.
Yeah, okay, I have this. Cool. So we have assembly, which is, of course, imperative languages. It's the machine code. We have C, C++, and Java, much higher languages, but still imperative, where we should specify each command. In the other end, we have declarative languages, like, for example, SQL. In SQL, you ask, bring me all the blonde girls who lives in Vilnius. For example, you don't have to elaborate how to do it, right? You just say it. Also in HTML, you say, put an image here, and it will do it. This is the source of the image. You don't go pixel by pixel and draw the image, right? You just say, this is the image, and this is the source, and you just need to declare it. And here, we see a nice example before React. We used to use HTML, which is a declarative language, and we use CSS, which is a declarative language. But when we wanted to update the UI, we had to go to the DOM element, to take the DOM element, go to the style, go to the color, and change it specifically to red. This is the example. We want to change the paragraph to red, and we have to go and imperatively do it. And it's really hard and it's really ugly, I think, to do it because it can be much simpler than this. So the idea of React was, oh, okay. The UI is a function of the state. Like any product manager can tell you this, right? It gives you the states, all the states of the application, and tells you what is the UI that should be presented. And with this idea, they invented React. But they say, how should we do it? How should we take advantage of this equation and to use it? Okay, not works so well. Okay, so they say, maybe you as a programmer, we need to find some way that you as a programmer can declare the connection between the state and the UI. And then React will efficiently update the UI for each change of the state. That's pretty basic. So if the programmer only one time, declare the connection between the state and the UI, and then all you need to take care of is the state. You don't need to take care of the UI. You don't need to go to the UI element and change it directly. Just change the state, and React will update it directly and efficiently. And they thought, how can we do it and it will be easy? Because we said it, but it's not such an easy thing to do. There is a big app, a lot of states. So they tried to find a nice way for us as a programmer to think about it. And they thought about a component base. And what does it mean? Component base means like everything in React is component. You have a text, which is a component, and you have a button, which is a component. They are actually the Lego parts of the component, but there you can build a component from a text and a button, and even a screen is a component. And if you want to take the screen and to put it in another screen, it's okay because it's already a component. So it's all a component. You can start from the small one and to make it bigger. And there are two.
Also hooks. Also hooks.
Yeah, hooks is something they invented after it, but I'm trying to talk about the basic idea of React. And there are two types of components. You can also say, oh no, there are a lot of types of components. Here I want to focus about the idea. There are stateless components and stateful components. If we can use stateless components where we just need to send the props to the component, for example, let's send the text to the label, and when we change the label, the component will be updated. It's okay. In stateful component, when we have much more complicated components, sometimes we have to have more complicated components, then we need to have a state. And every time we do a set state, the component will be, and the UI will be rendered, re-render. So in a stateless component, the UI is a function of the props, and in stateful components, the UI is a function of the prop and the states. Any question about it so far? Okay, great. Okay. I'm going back here, and I want to ask you a question. Is it enough for us? Can we do our whole app only with stateful and stateless components? What do you think?
No. Actually, yes.
Yes, no?
Yes.
Yes.
No. I think there is a mistake.
What is the mistake?
This. There shouldn't be this in the function of the component.
Ah, yeah, that's true. That's true. Okay. So ignore the this, and now try to think about the last question I asked. Okay. So yes, we can do it, as you said, but it will be really, really ugly, right? Why it's so hard to do it just with stateless and stateful components, the whole app?
You have to pass the state all the way down the tree or up the tree.
Yeah. Sometimes we will have like a spaghetti code, right? We have a lot of components. Sometimes the relation between them is really complicated. And sometimes we also have a shared data that is relevant to a few different components in other places of the tree. And there is a need for some external library, right? Some external store where we want to store all the data. It makes sense, and the need for external store to store all the data is not something that started with React, right? It was before that. And before React, the most common design pattern was MVC, where MVC is the model, view, and controller. The model is the data, where you put all the data. We have the view, you know what is the view, and the controller which manipulates between them. The controller take some data from the model, put it in a view, and when the users did something, he update the model, and that goes so on. So I tried to find some nice charts of how MVC should look like, how the data flow should work. And actually, I found a lot of different charts that shows with different errors and different directions of the flow. And the reason for it is that MVC is not defined really well. MVC is just the players. We have the data, we have the view and controller. Maybe some people say MVC is nothing. It's just the reality. It's what we have. And what happened when you work with design pattern that is not defined really well, that sometimes your app becomes a big mess. Like, you have a lot of places of the data, you have a lot of views, and they're all touching each other and change each other. And then you can predict how one change of the data will affect the flow, the data, the UI, and everything. And that's what happened to a lot of apps, and a lot of bugs happened because of this. And then Facebook thought, okay, what can we do? We want to find some smarter design pattern. And they came with an amazing idea of Flux, a unidirectional data flow. You know who those guys are? Someone? Don't be ashamed if you know. You know the guy there?
Yeah, I think it's One Direction.
Yeah, it's One Direction, yeah. And they are the models for unidirectional data flow. So React came, it was in the same talk, I think, and they presented React and Flux. They presented it together, but it's important to mention that Flux is not related to React. It's a design pattern where you can use in any client app that you have, but it goes really, really well with React. And I will show you the reason for it now. So let's see a chart of Flux design pattern, which is defined much better than MVC. And in Flux, you can see here we have the dispatcher, store, view, and action. Let's wait with the dispatcher and try to imagine where we have an arrow from an action to the store. Okay? If I have only action, store, and view. Looks similar to someone. What is it? If we have view, action, store, view, action, store. MVC, it's not exactly MVC, because in MVC, as we see, it's not like one direction and predictable direction, but what is it? This circle.
A loop.
It's a loop, but it reminds you something.
Agile.
If I don't call it a store and I call it state, what is it? It's like React, right? It's React. This is a stateful component. Like something Apple, like on-press button. We set state, and then React update the UI. That's the whole idea of React, this circle. React do automatically this error, and we on-press something, set state, and this is the circle of React. So the Flux came with the same idea of React. We want a unidirectional data flow. Okay, but we don't have one state. We have like, we think about it like we have a big store. Of course, for it will be comfortable for us, we will split it to few different stores. But let's think about all the app as one store. And we have a dispatcher. So what happens here? It's like something happened. Okay, the dispatcher is like a central hub that centralizes all the action. He knows, okay, action happened. I should update the store. I know how to update the store. And then the view will somehow know to listen to changes in the store. We need to take care of it as well. But we will have the same direction as React. Like the same thing we did in stateful component, we can do in our whole app. It's the same idea. React did this magic for us, right? We do set state, and this magic happens. Somehow, in the Flux library that we will use, we need to take care of this magic as well. You understand? You see the imagination between the Flux library, the Flux design pattern, and React? Okay. So those are the players of the Flux. And what I want to do now with you is to build a really, really, really basic Flux library together with you. Okay? If you use Redux, this might look familiar for you because the Flux library I'm going to build is the same like Redux. But I think if you use also Mobix and Remix and you use React, you actually use the Flux design pattern as well. It's the same direction. Yeah.
Would you say that in Mobex you flip or somehow change the roles of the special and store one with another or not?
In Mobix, you don't call it dispatcher. Sometimes just in using action, you just directly change the store. But I think it's the same direction, right? Like something happened, then you change the store, then you have like map state to props.
And then dispatcher, well, store and dispatcher, not the direction is changed, but they are changed place.
Yeah, yeah,
With one another.
yeah, maybe. In the idea, the direction is the same. The direction is the same. They call it in different ways, and yeah, you do it in maybe you can split the steps, but the important thing is here is that you have a predictable data flow in Mobix and in Redux as well, and that's what we wanted to achieve, and that's what wasn't happen when people wrote code in HTML without React and without Redux and Mobix. And here, if we want to build together a basic Flux library, what we want from a library is a store, right? Is a function in store. So all the library should do is to enable us to create a store and to give us the capabilities of subscribing, get state, and dispatch. Like we want to be able to subscribe to changes, right? One view wants to know every time something changed in the store. You want to be able to read the state, I mean read the data in the store, and you want to be able to dispatch actions. Are we okay with it? And but something is still missing to be enabled to create this store, and that's why we need to send a reducer. What is a reducer? Reducer is a function that for each state and action, return a new state. I mean, like the dispatcher, we need to, for each action, know how the store should be updated, right? Like the user pressed the increment or something, and we should update the store. So this is what the reducer does. This is the purpose of the function reducer. So when we create store, we send it reducer function, which enable us to do this. Okay, but before I build a Flux library with you, first of all, any questions so far? Looks familiar to you? You ever seen this chart? Okay. I want to show you first of all a small app. It's not relevant for the first part because the first part will be just build the Flux library. So it's not relevant to that specific app. But then we're going to use the Flux library for this app. So in the app, you see an NBA teams, right? And every time I press, I go to a counter screen. And in the counter screen, there is a counter. And the counter should be updated. We can increment and decrement the counter. And that's it. So it's only 2 files. Let's see the code, for example. There is the team list item, which is like this component. And we have the counter screen, which is this. That's it, 2 screens. Now we have like hard-coded counter, but we're going to change it to something we will read from the store. And also here, we have a button of increment, button of decrement, and a counter. Okay, are we okay with it? The app is clear for everyone? Awesome. You're pretty quiet. I don't know if it means that it's too obvious for you or it's too complicated. Okay. So first of all, let's build together a Flux library. Okay. So what we need from our library, remember, we want to export one function, which called create store, right? So we want to enable to create store function, which is a function that gets what the create store function gets? Reducer. Awesome. And eventually it will return three function, which is subscribe, get state, and
Change state or publish. Publish or change state. It depends how you want to design it.
okay. So in our case, it will be get state and dispatch. Okay. And what variables do we need in our store to be able to manage all this store?
Current state.
Yeah, we have the current state. And something else?
Subscribers.
Yeah. Awesome. Let's call it listeners, if it's okay for you. Listeners, it's a list of callbacks, which are, we let some view to be able to register to changes in the store. So every time something changed in the store, we want to call this callback and notify this view for changes. So the first function we're going to write is subscribe, which is a function that gets a listener and just push it to the listener list. In addition, I don't think I mentioned it here before, but the subscribe function returns an unsubscribe function that enables the view to unsubscribe in component will unmount or something like that. So let's return, in addition, some unsubscribe function. Listeners, filter L, where L is not equal to listener. Okay, so in that, if you call unsubscribe, we take the listener out of the list. The get state function is really, really, really simple. It just returns the state. Okay. And we have also a dispatch function, which is a function that gets what the dispatch function gets. Yeah, gets an action, right? Gets an action. And what it does, it updates the state. Who knows to update the state? The reducer, right. The reducer updates the state, called with the state, last state and an action, and update the state. And after it, what we need to do after the dispatch? Okay, we updated the state. Yeah, we need to call all the listeners, right? We go listener. Just call them. Okay? Pretty clear? And something I do here, it's something that will make our life easier, is to dispatch once an init dispatching. It will be easier for us as a user of the store to know that an init dispatching happened. So we call once with type init and payload, which is empty. Okay? Let's agree that each action contains a type and a payload, which is the extra data that you want to send. So that's it, I think, for the Flux library. And it's crazy because it's 26 lines with spaces. And it's some Flux library that we can use. Yeah?
Maybe there is a missing return at line number 8. Is it correct? No.
Line number 8.
At the beginning.
At the beginning, no, I don't want to return it. I just want to in my store, I want to take the listeners list and to take out the specific listener.
Okay.
You understand? Like I send the unsubscribe function to a listener, and when he called it, I just want to take it out from the list.
Also, just to make sure, does filter update the list in the place, or
No, you
the,
should assign it to
or you
listener.
Yeah,
should
you
assign
should
to
listener equals listener.
Doesn't mutate.
Where?
Because the filter doesn't mutate the
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 original
array
collection.
itself. Filter returns the new array, so you should write listener equals listener dot filter at line 8.
Okay.
That's
I think it will filter it out as well, but
no.
no.
Sometimes JavaScript does this stupid things that sometimes it does it in place, sometimes it does it you have to assign what to have.
Okay. Okay. Let's do it that way. Thank you, guys. And okay, so we have a Flux library. Are we okay with it? We can use it now. Let's create some app store. Okay. So we want to now we need to remember our app. We have a list of NBA teams, right? I don't have anywhere the list here in the store, so let's just create an init state where all we have in the state is a counter by team. Okay. Something that is important to mention, it's not going to be the most beautiful code you will ever see, because I want to really quickly to explain you a lot of things, and that you will be able to show all the connections here that happens in Redux. So it's not really beautiful code, but it's good to explain how the thing works. Okay. So let's create a reducer function that is relevant for our application. Each reducer function gets a state, which in default is the init state. This is really important for us. Then, as you remember, they call the reducer, the store called the reducer with the init type. So it will be the init state for the first time. Then we initialize the state. And it gets also an action. Right. OK. So what we want to do, let's do it. It's not so sophisticated here. Let's take the team name, which we will send in the action. OK. In the action, in the payload, we will send the team name. And we will have also the old value of the counter, which is state or counter by team in the team place. Because it might be undefined, I will do that it's a 0. I know it's not so pretty, but it's much already all the list of the teams with value 0, of course. But let's do it that way here. OK, so let's switch off the action.type. And we will have a few cases. Case number 1 is increment, right? We want to be able to dispatch an increment action. So if this happened, we will say that the state is now. Actually, what we need to do. I remember what you said, that it's not happened, but like if we change it, it won't work, but it will. So trust me. So if you go like this, and let's take the old value plus 1. OK? It's OK, and return the state. And if it's decrement, it will be the same with -1. And in the default case, we just need to return the state. It's really important to return the state every time, because sometimes the action is not relevant to our store. If you have a bigger app, then you will have multiple stores, and sometimes the action is not relevant to our store, but we still need to return the original state and not do anything else. So yeah, this is it. But what else? What we need to do with this reducer? What we want to do? But we want to use the create store function, right? Create store function that get the reducer. Okay, are we okay with what we have here? We have a store that uses the create store function of the Flux library. We send it the reducer. And we have a function in store now. With this store, we can do everything. We can subscribe to changes, we can dispatch actions, and we can read the state. Okay? All good, guys? Awesome.
But is it okay if we mutate the state?
No.
What did you say?
We are mutating state and reduce.
Yeah, it's you're right. It's much better to have an all new state and to assign it to 0. Like in Redux, you should every time some action happened, you should have a whole new state. You should distract but it still works, and it's much easier here to read it that way. But it's right what he said. The right code will be something like object dot assign.
Why not use pet operator?
Yeah, we can do it, but
You don't like it.
yeah, but it's still. Okay. So let's use this store. Okay. What we want from our store? We have a counter screen here, right? And we want to be able to listen to changes and to subscribe. So first, we want to subscribe. And what we do here? How we subscribe? Most of the time, when you use map state to prop, some magic happens, right? So you don't see what happens, but what's going on there?
Set state?
No, not set state, because it's not in our state. Hmm? No, we will use get state here. Here in the counter, we will use store dot get state, and we want in the counter by team. And I didn't mention it, but I have the team name in the prop. Okay, so this dot props dot team name. Okay, so here I read the state and presented it, but every time the store updated, I want to know this and to do something about it, right? So what's going on here in the subscribe function? This is the magic function of React. Okay, what we have here is force update. You know this function? You've heard about it? Okay, this is the magic. Every external library uses this function in some way. You can't just update to cause a re-render without calling this function. You can do it. You can cause a re-render or by setting the state, or by force update. So this is what happens in Mobix and Redux, React Redux, and so on.
And why do you mask a force update into some other function, into a closure, if you could just pass it? Is it some sort of beneficial? Or?
We can try to do it that way. Let's try. Maybe you can do it that way. If it won't work, we will see. It will be your. Okay. But we don't want just to subscribe. We want to be able to unsubscribe, right? So that was an interesting question, but we will check it later. Lev also have a talk today. Yeah, maybe. It's also not so easy to sync when you live code in front of 30 people, but
We're trying to help you.
yeah, thank you. But we have the unsubscribe function that we want to save in our class, and let's call it in the component will unmount. Okay, so every time we unmount, we want to unsubscribe and stop listening to changes. It will be much better. And here, let's what we want to do in the increment. When the user press increment, what? Yeah, dispatch. Remember, we use in the App Store, we have an action which is the type is increment, and we have an action where the type is decrement. So yeah, we can dispatch an action where the type is increment and the payload contains team name, which is okay. And it's the same in a decrement, of course. Just need to do decrement. And before I'm going to the next screen, let's see if that it works. So don't be a red screen. Don't be a red screen. Don't be a red screen. Okay, counter. Okay. As I mentioned, let's put 0 here, because I don't have all the list already with the teams. Okay, I have 0, and when I increment, it goes up, and when I decrement, it goes down. Okay, we are good. We're pretty good. So let's do it the same in team list item. And what we are going to do now, the same thing, right? We do this in the constructor. You see, I repeat the same thing over and over again. It might tell you that, okay, maybe we can do something more efficient, like map state to props. It really helped me to do that thing. And in addition, I need to, in the component will unmount, to write this. And if I ever the store to get state, let's do the same thing here. Let's see. Okay, we have lead points 0. We incremented it. You see that it's a little bit slow? 3. It's not just JavaScript. It's JavaScript, but it's another thing as well. There is any problem here? Beside the thing that we repeated the same code, something that is bad performance-wise, you think?
Everything is re-rendering.
Opa, okay. Everything is re-rendered, right? We have like 40 teams in the NBA. How many teams there are in the NBA? How much? 30, okay. And every time we update one counter of the team, we actually re-render all the components. Let's see it. Let's just do like a console warn here, like render. I increment once, and I have 30, right? 30 re-render, and it's bad, okay? And that's one of the other things that Map State to Pro does for us, okay? It just wants to cause a re-render when something changed and is relevant to our component. We don't want to cause a re-render every time something changed in the old store. So let's try to do this heuristic here somehow. Maybe we can do smarter thing than just force update. Okay, let's just keep some old value. Okay, and let's say the new value is this, and when we want to force update, every time when something changed, right? Like if the new value is different, is not equal to the old value, then we want to force update and to update the old value. Makes sense? Map state to corpse does the thing for us every time, but it's important things. Like we don't want to update every time. So let's see if now the render happens only once. Still have the console. Oh. Let's see. Only one render. It's much faster, I think. No, it's fast now. I think it's pretty good.
Is that all the value?
Hmm?
Can you go back one scheme? So
Yeah, 26,000, because we still have counterbaiting. And that's it, I think. Any question about what we did now? So thank you very much. Thank you very much. It was a pleasure.